welcome to this webinar. My name is Andreas Blumauer. I'm from Semantic Web Company, and today we will talk about Semantic Web for developers. So I think it's going to be a pretty exciting webinar. We will do a lot of demos and live demos, of course, and show you possibilities for developers and, of course, also for the end users, how to make use of semantic web technologies. So therefore, we've set up environment. We can play around a little bit with the API of semantic web technologies. And we also will showcase end user applications on top of that. So today we are 3 presenters. I will start with a short introduction and we'll pass over to my colleague Jurgen afterwards. He will talk about the PoolParty API. We'll give an overview how to make use of PoolParty technologies in general, how to use the API for different purposes, and how to put the application layer on top of the API. And then passed over to my other colleague Florian, who will show you typically the methods and the ways how to build an application on top of the PoolParty API. Yeah, welcome to everybody. It's a little bit after 5 o'clock now here in Vienna. People still arriving to this webinar. And I will start with a short overview and introduction. So who are the people behind PoolParty actually? Semantic Web Company is on the market since 2001. So you can see we are not a typical startup anymore. We are 20 experts working on linked data technologies and semantic web technologies, and have launched a product in 2009 called PoolParty, which is good for building semantic web applications. We serve global 500 companies and have partners in the European Union and in the US who are experts in their fields, most often in the field of taxonomy and thesaurus creation, linked data technologies too, and also system integrators. So semantic web technologies typically are integrated with legacy systems, legacy data systems, with enterprise resource planning systems, content management systems, and things like that. So just a short overview over some customers we're proud to serve. You can see there is finance industry, there is pharma industry, there are NGOs, cultural heritage, education, learning, and media industry. So those are, I think, typical companies making use of semantic web technologies. All those who deal with a lot of information, who have to answer probably also complex questions. And also the interesting part of especially media industry, I think, is here how to make use of linked data to publish information in new ways. So there are a couple of typical solutions on top of semantic web technologies. I mean, one which is most obvious is vocabulary management, which can also be used inside corporate boundaries just for solving a little bit the semantic puzzle to overcome with the Babylonian language confusion. Another typical solution is text mining. You can build on top of semantic web technologies. There is, I think, a pretty new one in contrast to text mining solutions you can build on top of semantic web, which is the enterprise linked data integration. A new way to do data integration, very agile and flexible way you can make use of if you use linked data technologies. Recommender systems, if you in the area of, let's say, content management, and you would like to find out related information to content the user is focused on at the moment, that's something which can be dramatically enhanced by using semantic web and linked data technologies. Then from a more technical perspective, how to make content management more efficient, also something you can improve by using semantic web technologies. And last but not least, the interface to the customer. I think a very important core process can be improved by semantic web technology when it comes to transfer knowledge from the vendor, the technologist towards the customer, who is usually talking or speaking another language than the experts would do. So here also semantic web technologies can help to improve those kind of interfaces to the customers. So what's in its core? Semantic web technologies always rely on knowledge models. A knowledge model can be from very simple to very complex. We here at Semantic Web Company think it should not be too complex, but not too simple. It should be as complex as it's necessary. Only it should not be, let's say, on the high end. We typically have old ontologies which turned out to be too complex in industry scenarios. On the other hand, if you think of a simple, let's say, synonym lists, they also turn out to be too simple. You can't really express a lot of knowledge by such lists. So somewhere in the middle, we have found out thesauri seem to be a good solution approach. And thesauri are in our core technology. The core model always is built around SCOS, which is a standard to build thesauri on the semantic web. And by doing that, we teach machines to extract meaning from data sources. So that's just a brief snapshot of thesaurus and the thesaurus management tool we have in place, which is one part of the PoolParty product family. So before I pass over, hand over to Jurgen, who will start to give you a more detailed technical introduction to our technology stack, I would like to leave you with this picture. We think that semantic web technologies and linked data methodologies can really help large enterprises or also medium enterprises to grow or help to grow their knowledge, which means you could start to create a knowledge graph as a little knowledge graph in first hand, and this one can be enriched by further data from various data sources. Could be a product database, could be an external database. And later on, you can align this enriched linked data graph by even more data. You can really grow your knowledge by using linked data technologies in a very flexible and agile way. It's a different approach to handle data and information than it was when relational databases were in place. They were, let's say, very rigid in terms on how to grow in parallel to the way your business grows, to the way the knowledge of your employees grow or the market itself develops. So linked data technologies are very flexible way to express knowledge and to let the knowledge grow. That's the idea what we are following here. Okay, so that's the first more technical slide now. Just a brief overview before I hand over to Jurgen. Just wanted to leave a couple of words what PoolParty stands for. It's 100% Java. You use Tomcat. We have triple store technologies in the background. On the front end, we use JavaScript. It's browser-based, as you can imagine. And now we will walk through all the different components. There's an editor, there's a wiki, there's a Sparkle endpoint, and so on and so forth. So you will see in a very detailed way now how our technology works. And I will now hand over to Jurgen.
Hi, thanks, Andreas. My name is Jurgen. I'm a developer for Semantic Web Company since 2006. My main focus is on PoolParty Thesaurus server, semantic web, and linked data development. Today I'm going to give you an introduction on how to access data produced with the PoolParty suite. I'm going to show you from a developer perspective on how to bring PoolParty content to the end user. In other words, I'm the guy with the red pullover and serving this white shirt guy. Now, I'm going to talk about the following parts. We have set up a small sample application to which you will also get access. That will demonstrate how to access data from a knowledge graph produced by PoolParty by dereferencing URIs, by running Sparkle queries, and by making calls to the PoolParty API. It will show how to make calls to the PoolParty extractor and the PoolParty search by using PHP in this case. Since we're using common standards, these examples are easily transferred to other programming languages like Perl, Python, or Java. Now, we have set up this small demo page, which will demonstrate how easy it is to put all these components together. Dereferencing is the simplest way to retrieve a representation of a linked data resource. It's basically doing a HTTP GET on the resource's URI. With content negotiation, you tell the server which RDF serialization you're accepting. Common MIME types for the RDF data model would be application RDF and XML or text turtle. To show you how flexible this is, I'm first going to dereference my FOV profile with this little PHP class. It retrieves the data for my FOV profile in RDF XML format. You can see I have a big FOV profile with a lot of information in there. Every common RDF library is easily able to parse this data. Now, what I did is I put together all API offerings we have, and this, for example, is a call to the list project API service. I'm going to choose a project. I have a small Sparkle query that will do a lookup in the real thesaurus. I'm going to choose climate change and do a dereference on that URI as well. You see there's a lot of data there. It's again in RDF XML. As you can see, there are also not only cost triples, but there are also other triples as well. These are coming from PoolParty's metadata management. So if data is changed or added, there are always DC terms type modified date is set, and the contributor is that set, and stuff like that is managed automatically. Now, with PoolParty API, we have a wrapper API for Sparkle queries that is easily extendable. Its main focus is to provide developers a means to get started at the moment, for example, without having to learn anything about Sparkle. There are three main components of the PoolParty API that are the project services, the thesaurus services, and the list services. The project service will give you information about the project in various with various parameters. The thesaurus service will give you information about thesaurus, and the list service will give you information about lists and collections produced by PoolParty thesaurus server. All these services return data in JSON format, so you don't have to bother with Sparkle or Sparkle queries or content negotiation. You can implement all these functionality with ease. So I'm going to show you the list projects service. It is a simple service call which produces, in this case, HTML. The response format from the API will give you a simple JSON format for each project with its ID, description, subject, title, URI, default language, and other available languages. Now, if we take a look at the source of the PoolParty API client, the first PHP file is only a proxy that's delegating the Ajax calls and does some formatting. The real magic is in this very simple class. You see, it's simply a curl client that getting HTTP that puts HTTP gets to the API URL with the according parameters. Now, this get method works for every part of the API. So there are a couple of methods that accept a get, and so I can use it with simply giving it the appropriate URI, and it will show me the result in JSON format. Now I can list the concept schemes. This is another very simple call to the thesaurus server. I just need to give it a project ID. The JSON format in this case is also very simple. It simply consists of the URI of the concept scheme plus the title in the default language. Now I need to set one single concept scheme as the current concept scheme to list its top concepts and make a call to the list top concept API method. This way, along with these three methods, you can easily navigate through the whole thesaurus without ever having to issue a Sparkle query or thinking about MIME types. The Sparkle is one of the most important features we offer. We integrated Sparkle 1.1, so there are many possibilities even for enterprises. You have all these aggregate functions and property paths that come with Sparkle 1.1. Also, we have the possibility to implement custom Sparkle functions for different use cases. I'm going to show you one example that implemented a Levantine function, which is very useful for finding similar labels. In case you're only starting to use PoolParty, you might have lists of labels in some sort of storage, be it an Excel file or whatever. And experience has showed us that there are doubles, so there is hardly any quality assurance. You can use such queries for quality assurance and make sure, for example, that that house and houses are not two separate concepts in a thesaurus. Now, a simple select would look like this. Again, I have a proxy PHP file that's delegating to a Sparkle client PHP class. This PHP class can be used for more or less any Sparkle client. It might differ with one or the other URL parameter, but in basics, it's usable. So you program one single Sparkle client and you're done. You don't have to worry about other data formats again. Now, I'm running this this Sparkle query where I select all course concepts, limited by 10, of course. From the real thesaurus, I get the results in Sparkle results and XML. I'm doing content negotiation. Content negotiation is, of course, supported by PoolParty Sparkle endpoint. I also could retrieve the same result in JSON. If you do it with a JSON accept header, you can even easier parse this, for example, in JavaScript. Now, a simple construct query. This is the second type of Sparkle queries besides select query. As with a construct query, you are constructing a subgraph in a certain MIME type. A construct query will always return basically a set of triples in a certain serialization. I'm going to construct the data from one single resource using application RDF XML. If I run this query, I see again it's basically the same as I would as if I would dereference this URI and accept application RDF XML as a serialization. Now, of course, as you have seen before within the dereference tab, Sparkle in the meantime, and especially OpenRDF in the meantime, are fast enough for even autocomplete searches. This would be an example of retrieving all course concept whose pref label contains energy. You can use any regex here. I'm simply going to do that with energy, and I'm accepting Sparkle results plus XML again. Now this takes some time, but it should be fine. So we have a list of resources where energy is in the pref label. Now, for logging purposes, it might be useful to check, for example, what concepts in the PoolParty API in the knowledge graph did change recently. So I'm going to show you an example of how to filter for modified queries. This will give you all resources that changed since 2012, and you get the information here. Now, for aggregate functions, these are very useful for not only for statistics. I'm going to show you a short example of counting all course concepts in this special project. There are nearly 2,000 course concepts. There are 4 concept schemes, and to get an idea of how interrelated the resources in this thesaurus are, you can do a query like this where you count the narrower relations. Now this would be over 2,000. If you have a large number of concepts and a very low number of relations, you can assume that you have a flat list. So you should manage your thesaurus to have a better structure. Now, property path will give you an idea of how will give you the result of how Sparkle how resources are related to each other. You find transitive transitives with property path. I'm going to list all the narrower transitives. This little plus does the trick from this resource. Now, this is also usable, for example, if you want to check in which concept scheme a certain concept is. Now, I find no matter how deep it is in the structure, I find out very fast that that this concept is in concept scheme with the URI glossary number 1. And I give you another example of the Levantine function. In this case, I'm searching the reader knowledge graph on pref labels that are very similar to biomass, and I'm getting things like biogas or biogas with Z and biogas with a uppercase B. So if I do this in a quality assurance environment, I would see that that there would need to be some actions. If I have if these URIs would be different. In that case, they are only French and German, so they are different languages. But I could restrict the query to the same language. If I see that there are very same labels, I can merge them in PoolParty. Now, I show you shortly the source. Again, this is a proxy delegating the calls to the Sparkle class. This is a one-time Sparkle class. You write it once and use it anywhere. It's really no rocket science. It's basically delegating a query via a curl call to a certain server and doing content negotiation. It doesn't get more complicated than this. Now, PoolParty extractor will give you the possibility to extract concepts created by PoolParty from full text. There are 3 main features. It's the extract API, the extract service, the mapping service, and the suggest service. Since we are running a solo server in the background, we can use the information, the term dictionary of Solr for very, very fast auto suggest queries, using, for example, for autocomplete or term statistics and stuff like that. We have the mapping service, which will do the following for you. If you have a certain ontology or RDF in any format, for example, a Scostosaurus or any ontology with labels in it, you can send this ontology, for example, with all its labels to the mapping service, and the mapping service will extract the labels from the ontology and replace it with URIs from the concept. So you can align your ontology with your controlled vocabulary. Now, the extract service does what its name suggests. It extracts. I'm going to show you that with the with the real thesaurus. I'm going to use the first paragraph from the sustainability wiki and paste it in here. Again, there is a proxy PHP and a a PoolParty extractor client that basically does a curl call with the correct parameters. I'm going to send this text now to the extractor, and again here I can accept application RDF XML. I will get the results in this very special format. Now, if we check the results, there are two types of results. You can see the RDF type is a SCOS concept. The SCOS pref label of the extracted concept is sustainability, and the URI is glossary 1128. So this is a concept that was found in the thesaurus and was extracted from the text. It's of type SCOS concept. It's you see it has a score of 100 points, and it's in a certain scheme. It's in concept scheme number 1. Now, the other type of extraction that is done by the extract service is that it extracts via term frequency analysis terms that are not already in the thesaurus. So when analyzing such an extraction result, you could see that you need to enrich your thesaurus, and for example, environmental or something similar to environmental is missing in your thesaurus, you would create such a concept. Again, I'm showing you the source. This is a proxy server, and there is one single method that puts forward via curl the URL parameters along with the plain text to the extraction service on Pilot 7 on this PoolParty server. Now, another component of PoolParty is the PoolParty Search component. With PoolParty Search, we have basically 3 methods. Again, a suggest method. That's the case because we have this again a Solr index in the background, so we use it. We have a suggest method, and we have a search method. Now, the way indexing documents works for PoolParty Search is the following: we get texts in any format. We transform these texts to RDF, and we set up the PoolParty Search indexer to look for certain properties in this RDF file that describes a certain document. Now, there are certain properties that are that trigger a full text extraction, for example. Now, when the PoolParty Search indexer comes across such a predicate, it takes the value of the object of such a statement and sends it to the PoolParty extractor, which will enrich the RDF graph that describes the document. So in short, we have a plain text document. It becomes an RDF graph with a full text in it somewhere, with some predicate, and the plain text of some predicates is sent to the extractor, and the extractor updates this document graph with an extraction result. The extraction result, the enriched document, is then indexed in a very special way, and we can use it, for example, for autocomplete searches. I'm using here for this autocomplete the suggest service from PoolParty Search. I'm choosing energy efficiency. Now, the suggest service will look for labels that are extracted and come from the thesaurus. So it made sure that I'm retrieving documents that are tagged with the URI of which energy and efficiency is one of the labels. Now, what you see on the left side here are the facets. Now, energy efficiency also stands for a concept scheme, and these facet values are all concepts in that concept scheme. The same here, climate compatible development is a concept scheme in Regal Thesaurus, and all these labels are actually not labels but URIs. So we are basing our search on URIs, making sure there is no confusion with labels. Now, if I choose, for example, domestic heating, all these, again, another call to the PoolParty Search is made. Setting up the filters for the search. The filters are always URIs. I'm searching for documents that are tagged with certain URIs. If I hover over these facet values, you might see that they correspond to one URI in the Regal Thesaurus in the status line of my. I don't know. I'm not quite sure if you see that in the status line of my Firefox browser. Now again, this again is no rocket science. We have a proxy, and once, oops, that's the PPX client. Still, it's nonetheless not any more complicated. The length of the file is basically the same. It does a curl call, sending a JSON structure, which I'm producing with JavaScript in this case. It sends a JSON structure to the PPS search service. Contained in this JSON structure are the fields that I want to restrict my documents to. For example, I want to restrict my documents to I want to restrict my document list to documents that are tagged with a certain URI from the Regal Thesaurus. Now, last but not least, if you really have some extra special needs that are not possible to be fulfilled by API or Sparkle queries, there is yet another possibility. I'm just showing you the source code of this. The PoolParty server exposes its core data connection via a Jindy resource. So in case you're programming in Java, you can create any web application and access all the data with the OpenRDF Sesame API, and you have access to this bindable local repository manager and to all repositories via the Java API with ease. So now I'm going to hand over to my colleague Florian, who will give you an idea on how our customers use all these features.
Hello, my name is Florian Hoover. I'm technical consultant for the Semantic Web Company, and I want to show you the integration and solution part of this webinar. So I want to tell you something about the usage of PoolParty technology and PoolParty APIs. So we start with two projects that are based on the PoolParty technology. This is the GBPN, and second project is the Regal API. Then I want to tell you something about the PoolParty Semantic Search. And finally, I will present you a little mini application that I developed to get in touch with the PoolParty APIs. I called it Concept Drift. We start with the GBPN with global buildings, with the Global Buildings Performance Network. And this is a network with the mission to reduce energy consumption and carbon dioxide emissions from the building sector. So the GBPN page provides nice tools and databases, and also provides a glossary. And one of the goals of GBPN is to allow consistent tagging of content. So the content of the GBPN is built on a Drupal content management system. So the content is tagged with based on the Drupal taxonomy, but the management of the whole thesaurus is done with the PoolParty Thesaurus Manager. So they are able to tag blog entries and RSS feeds, as I will show you in a couple of moments. So the interesting part is how is the PoolParty server connected to Drupal to provide some nice visualization, as you see on this side. There's a synchronization between the PoolParty Thesaurus Manager and the Drupal taxonomy, and this synchronization is done with an exchange of an RDF XML file. So this is done daily, and the Drupal taxonomy is filled up with all the information that was managed in the PoolParty Thesaurus Manager. So I want to show you this application live. So we are here on the GBPN page, and we can step into the blog. We see here right now some categories. These are the concepts that are defined in the thesaurus, and every blog entry is tagged with some concepts. So you can read the definition of these concepts on in this box on the right-hand side, and maybe you're interested in a specific concept, so you can step inside the glossary viewer. So this is a nice tool to navigate through the thesaurus. Here the GBPN thesaurus is the starting point, and there are a number of concept schemes that are linked to this thesaurus. So you can step into the next level. Let's say we choose environment, the top concept environment, and here we see a number of top concepts, and we can go in the next level. So we select the concept emissions, and we find here narrower concepts. We can select one of these concepts, and well, we can view the definition of this concept here. So all of these links and the definitions are managed in the Thesaurus Manager. Well, the next interesting feature that I want to present here is the news aggregator in the newsroom. That's my favorite feature on this side. So here it is possible to extract RSS feeds that interest you most. So you can select here a number of concepts, and the RSS feeds are tagged automatically. So there's an automatic extraction and tagging of the RSS feeds provided by PoolParty technology, and you can select the fields that you're interested in by a click. So maybe you like to know something about emissions in Asia, and you see the restriction is active, and I can get this RSS feed and integrate it in my homepage. You can see the parameters are inside the URL. They are encoded in the URL, and well, now you can use this RSS feed maybe in NetVibes and follow these RSS stream separated by the selection you made earlier. So the next feature, the next project, the next example that I want to show is the Readly API. Readly is a clean energy information portal, and the Readly API is an application initiated by REAP. That's an acronym for Renewable Energy and Energy Efficiency Partnership. And the Readly API consists of two services. On the one hand, an API for automatic tag extraction, and on the other hand, a content pool for documents in the field of clean energy. And the idea behind this solution is to allow consistent tagging. So it's similar to GPPN. And the second goal is to establish a semantic index where documents can be stored and retrieved by the renewable energy community. So in this slide, there's a simple overview of the tag extraction. So you send the document to the Readly API. Here behind the Readly API, there's the PoolParty extractor API that we've seen earlier from Jurgen, and you get topics and concepts, get locations and keywords, and you can use this information to enrich your documents. The second part is to store documents in the content pool. So you deliver documents to the content pool. They are automatically enriched, and later you or someone else can receive these documents. I will show you these services live in a couple of moments. I want to show you now the organizations that use these technology. There's a number of users, but here I show you some of them and their use cases. So the Open AI provides a widget to suggest related articles. Aldis uses the Real API to offer the users information about the definition and synonyms, and we adapt uses the Real API for consistent tagging. So the four services that are provided by the Real API are an extraction service, the content pool push service, the similar document service, and the recommender service. So I want to show them live. We have first we have to register on the Real API web page, and when we are logged in, we have to select a project. We have to register a project where we get the token. When we have this project created, we can use the very nice request builder. So with this request builder, it's possible to generate the requests by it's very easy to create this request. So I'll show you this right here. So usually I'll tell you this right now. So when you're interested in specific documents, so maybe you're interested in a specific topic like wind power, and want to know something about wind power in, let's say, Germany. You can select the language that you are interested in and create the request by click. So you see here the request URL. To do the REST call, you can click on this URL and get the result in a JSON format. So you see here a list of documents that that were recommended. Well, and similar to this, there is a similarity service that is also provided by the Real API. So you can use this similarity service to find documents that are similar to a specific document. And usually when you push a document to the Real content pool, you receive a document ID. So this is an usual use case that you want to show documents that are similar to your own documents. But I haven't sent any document to the content pool, so I take this ID that I gathered from the recommendation. So I use this ID, put it into the search field of the similarity service, So this is my test project. This is not so interesting. I could also restrict to some sources, but I want to search the whole all sources. So again, I use English and German as the language and create a request URL for the similarity service, and I receive a number of documents that are similar to the document that I found before. So this was the nice request builder, and there is also a nice statistic feature in the Regal API that is can be used by the administrator. So the administrator can see which concepts are very trendy, so how often they were extracted, and the administrator can watch the number of requests. Maybe, for example, here the extraction requests. So the next thing I want to show is the PoolParty Search. We built an index based on renewable energy articles, and again the Regal thesaurus. So you see there are more than 70,000 documents in the index, and like Jurgen told you before, there is also here there's the facets built on the concept schemes, and here you see the concepts. And the interesting thing I want to present now is that you can see that this search application is based on semantic knowledge models that when I select maybe wind power is a nice example. When I select a concept like wind power, you see here a knowledge graph box. So this box contains the information provided by the knowledge model. We have here a nice thumbnail, the description of this concept. We see here alternative labels. We see related concepts. So these are concepts that I can use for another search. For example, here it's possible to say, okay, wind power is too general for me. So we found more than 2,000 documents. I want to know something about wind power technology. And here we go, and we see that there are only 10 documents in this query. And well, someone who's interested in wind power technology can use this information. You can play around with this. There are the links are provided to you. So a nice example is also the carbon cycle. It has a nice thumbnail here, and you can say, okay, carbon cycle is too specific. I want to know something about carbon first, and then you can step into the specific terms. This idea of navigating in the thesaurus is also used in this mini application that, like I said before, it's I built this to show you the different possibilities to use the PoolParty API. So we are linked here to a server. This is the really project, the really knowledge model, and we can, like before, we can use maybe wind power. This is the suggest function that Jurgen explained earlier. So we have now fired a lot of AJAX requests against the PoolParty API. First of all, the description of the selected concept is listed here. You find the narrow concepts, related concepts, the description. So we saw this description earlier in the PoolParty search. And another thing that I made here is an extraction of this description. So you see that there are some concepts found within this description, and there are also tags that are extracted, which can be used as maybe for the improvement of the thesaurus. So you find here maybe a new label that is interesting. And in this little application, you can select these concepts, and you see that the content is changed. So here the concept wind turbine is presented, and so you can drift through the thesaurus. This is the name behind the idea, and you can play around with it when you want. Well, the links are provided by you can follow the links and well, play around. Well, this was my talk. I will hand over now to Andreas again.
Yeah, okay. Thanks to my colleague, thanks to Jurgen, and thanks to Florian. Have a good evening, a good day wherever you are, and let's stay in touch. Bye bye.